Vance and Hines is going to produce the engines for the streamliner. They've done a lot of drag racing and they're very successful at that. Road racing, you name it. So I'm very confident that this thing is going to work and work well.
I think the biggest thing for us to get involved in a project like this is to be concerned who you partner up with. Sam Wheeler's an obviously a tremendous amount of experience with the motorcycle going to Bonneville. Parts Unlimited, Fred Fox, that speaks for itself. His involvement with the Easy Hook and my partner's enthusiasm to do this really makes it a no-brainer for us to jump on board.
I had the luxury of meeting Sam. We did an NHRA seminar, and I was very impressed with him. I thought he was very reserved and very humble. Great guy. I was really impressed with him right away. Very smart, obviously. But I was also impressed that he didn't have to brag about who he was and what he'd done and all that stuff. He was more answering questions for individuals in a way that you would respect. So when there was an opportunity for Vance and Hines to work with him, I really wanted to jump on it. And then it worked out perfectly because Parts Unlimited Drag Specialties was involved with the project in addition to Sam, so it was perfect for Vance and Hines.
On Sam's project, in years past, he used to run the ZX11 motor, and for this speed attempt, he's going to be switching over power to the Suzuki Hayabusa. The great thing about the Hayabusa is the engine platform has been around for 10 years plus now, as well as it's proven. It's a very reliable power plant to make good horsepower. You can take and bolt a turbo on the Hayabusa with all the proper equipment and make 600 horsepower reliably. Sam, according to all data and records, we don't really need 600 horsepower, so I feel the great thing about it is we have that possibility to have power on tap. You have reserve. That way, if you can't get the efficiency that you need up front and everything in the early part of the track, hopefully we can use a little extra power for the second half of the track and get him to his goal. Some of the key features that we're doing to Sam's engine is adding cylinder studs and lower end studs to the motor. As you're feeding boost into it somewhere in the neighborhood of 20 to 40 pounds, you need to keep your base foundation, which are the engine cases, obviously stable, and you want to keep them from wanting to pull apart or fretting or doing anything weird. One of the components that we're utilizing that is OE Suzuki will be the crankshaft. Suzuki made a really good crankshaft. It's from the 2007 and earlier models. It's actually a 2mm larger stroke, which gives us a little more displacement using the same bore. So the crankshaft has always been a pretty good base foundation in that engine, and nobody's had really trouble with it, so there's no reason to change something that Suzuki intended for the motor and works really well. Next component we will be using is Carrillo connecting rods. The H-beam connecting rod is definitely going to be a key feature. As I stated earlier, you're going to be somewhere in the neighborhood of 20 to 40 pounds of boost in between that range, and you want to make sure you have the power that you use is efficient and it keeps it from wanting to twist or move the connecting rod around. So we went to Carrillo and we're going to use their H-beam connecting rod, and we've had lots of success with them. On top of the connecting rod will be a CP piston. We chose to go with one of their turbo design pistons, which lowers the wrist pin down a little bit, raises the deck up, gives you a little more ring surface area. The end result is you have a nice stout package between the rod and the piston, and it will give you that whole total overall package of reliability and less chances, hopefully, for failure. For the cylinder head, we are doing all the work here in-house. Obviously, Vance and Hines has a long history, and Byron Hines from years ago, that was his forte, was the engine side of things and producing horsepower. For the cylinder head, we're taking our standard 2012 Hayabusa cylinder head. We're gonna do what we call a turbo port to it. A little bit of intake work, a lot of exhaust work. On the cylinder head, we're gonna take and do some porting as well as an O-ring. That way we can make sure under all those extreme pressures that you're holding in and you're giving a little extra squish to that head gasket. Once the cylinder head's all ported and finished, the next thing from there is to furnish it with some valves. On the exhaust side, we're gonna use a super alloy exhaust valve, which is gonna really help sustain the high temperatures and anything possible that subjected abuse that valve may see. We don't want that to fail. So we're gonna use a supertanium, they call them, and it's It withstands temperatures up into the 1900, 2000 degree range, which I wouldn't be shocked if you're seeing exhaust gas temperatures around 1800, 1600 with the turbo for that long of the application. On the intake side, we're going to stick with the titanium intake valve. The intake valve, one of the key components is you're using your intake charge, which is going to be cooled by an intercooler. So that's going to really help keep the intake valve cool. And obviously, the intake valve being the heavier of the two, the end result of that is using that in a titanium is going to better control the valve train. For us, valve train control, it's going to be sitting at probably somewhere in the 10,000 RPM range for a matter of 30 or 40 seconds. And one of the hardest things there is you're trying to keep the valve train all in harmony, is the easiest way to say it. Here at Vance and Hines, we use a Newen valve job machine. The nice thing about the Newen is it is a fully contoured valve radius, basically, on your seat. It's not like a standard seat cutter that would have, let's just say, a 45 and whatever back cut angles you choose. That machine, the Newen, allows us to actually do it's a contoured radius, and it has a very smooth profile. It allows you to go down into the neck of the seat and of the beginning of the port, and you can really have a smooth transition. And the nice thing about it is you're not set on certain angles. You can do that contoured radius that really smooths out airflow and helps better it at low lifts or at areas where the valve may be getting very close to the seat area. It still allows air to get in without creating any obstructions. You know, in a quarter mile, most of these engines only have to live for 7 to 8 seconds while you're making that pass. With Sam, we have to make that engine live for about 50 seconds to a minute of pure acceleration, and that means that's just flat out. It's going to be 10,000 RPMs, and you're going to see some high exhaust gas temperatures and everything, so it's definitely going to be built to be durable.
I really and truly hope, not just for Vance and Hines, but for Sam, that he accomplishes this goal, because it'll be very hard for anyone to go to the next level after 400 miles an hour.